Okay, so today's lesson we were going over solving absolute value equations and inequalities. So our goal for this was to solve the absolute value equations and inequalities and use them to solve some real life problems. Okay, so absolute value, as we mentioned previously, is the distance from zero. So it's always a non-negative number. So a lot of people say absolute value is always positive, and that's because distance can never be negative, right? And we talked a lot about, if you drive a car forward, right, you're covering so many miles, maybe you're driving 5 miles or 10 or 20. If you drove your car in reverse, even though you'd be driving backwards, you'd still be covering a positive amount of miles. Okay, so if the absolute value of a number x equals c, then that means x can have two possible values. So if absolute value of x equals 8, for instance, then that x value, could be positive 8 or it could be negative 8. So why is that? Because if you had an 8 inside those absolute values, the number 8 is a distance away from 0 of 8 units. If you had a number of negative 8 inside your absolute values, that would also be 8 units away from 0 or a distance of positive 8. So because of that, when we solve an absolute value equation, we have to take account for both directions, okay? So that negative and that positive 8 are the two different directions on the number line that you could go 8 units. So you can walk 8 units forward, you could walk 8 units backward, or you could drive 8 miles forward, or you could drive 8 miles backward. So that's why we have the positive and the negative. So when we're solving an absolute value equation, we need to account for both directions that we could go, or both directions we could move to achieve that distance. So when we go to solve these two equations here, the first one, we have 6x minus 3. We always want to make sure that absolute value is isolated on one side of the equal sign before we attempt to solve it. So 6x minus 3 could be equal to 15, or 6x minus 3 could be equal to negative 15. And that's because if I had a 15 in those bars, that would come out as a 15. If I had a negative 15 in those bars, that would also come out as a 15. So both of those numbers, 15 and negative 15, have the same distance. So we don't know which of those numbers the 6x minus 3 is representing. So once you write it down the two different ways, you're then just using your basic algebra skills to solve for x. So adding the 3, dividing by 6, and we have x equals 3. Then on the other side, we're adding 3, negative 12, divide by 6, x equals negative 2. Okay, so then the second problem here, we have the same concept. Whatever is in those absolute value bars could be equal to 9, because the absolute value of 9 equals 9, but that 2x minus 5 might be negative 9, because that would also come out as a 9. So since I'm not sure which one of these my 2x minus 5 is equal to, I would have to count for both possibilities. So 2x minus 5 equals 9. 2x minus 5 equals negative 9, and then I'm going to use my solving skills. So 2x equals 14 divided by 2, x equals 7. Over here, 2x equals negative 4, and we divide there, and we get x equals negative 2. Okay. So now, as far as an inequality is concerned, similar idea, whatever's in that absolute value brackets could be different things again. However, it's a little bit more detailed when we have these inequalities. So if you have a less than sign like we do here, you're going to make this into an and problem. Okay, an and compound inequality. And my corny way from remembering that is I write less than That's how I remember that. That's what it is. If you, however, have a greater than or a greater than or equal to sign, I always remember this as being greater. So I just pretend that I spell greater with an OR and it's an OR. Okay, so now if it's an AND problem, you would take whatever's in those absolute values, right? That goes in the middle, and you're saying that's got to be less than C or greater than negative C. And then, of course, if you were to graph this on the number line, you would have your negative C and your positive C, and your shading would occur in between those 2 points. Just like in the OR, you're saying, okay, this number could be greater than C, or it could be less than negative C. So if here's negative C, it could be over here, or if here's positive C, it could be over here. Okay, so the main thing for those is you have to look at your sign and decide which one is it, an and or an or, and then you can kind of set it up and solve it from there. Okay, so solving and graphing the absolute value inequalities. Again, you need to make sure that this absolute value is isolated. So the first thing I need to do is move this 1 here over to the other side. So now I have the absolute value of 2x plus 7 is less than 11. Now I want to look and see, well, what kind of inequality do I have? So less than means I'm going to have an and for this one. So because this one is an and problem, my 2x plus 7 is going to go in the middle. My less than 11 over here, but then I have to put another less than sign pointing the same direction, and then negative 11 over here on the left. So what this is telling us is that this 2x plus 7 is greater than negative 11, but less than positive 11. So we know it's somewhere in the middle of those two numbers. And now we can go ahead and solve for that x value. So we have negative 18. And over here, we would have a 4. And then we have negative 9 and 2. So x is in between negative 9 and positive 2. And if I were to graph that on the number line, I would have my negative 9 somewhere on the left with an open circle, my 2 somewhere over here on this side with an open circle, and I would shade in between those 2 points. Okay, so now let's go on to the second problem here. Now this one, again, we have this number out here, this 2. We need to isolate this absolute value 3x minus 2. So we have to divide that 2 out. Some people might want to multiply or try to distribute, but you don't distribute to absolute value. You could distribute parentheses, but not absolute values. So this is now 3x minus 2 is greater than or equal to, and 36 divided by 2 is 18. So now we can look at our inequality sign, and this is a greater than this time. So because it's a greater than, it's going to be an or problem. So that means I'm going to take my problem, I'm going to say 3x minus 2 is greater than or equal to 18, or this 3x minus 2 could be less than or equal to the negative 18. Because remember, if it's less than the negative, it's going to be all the way on the left of the number line. And if it's greater than number, that will be shading the right side. So now to get those actual values for x, we're going to solve each of these inequalities. So 3x is greater than or equal to 20. And I'm going to get x is greater than or equal to 20/3. And to write that without the mixed, or sorry, with the mixed number, 3 goes into 26 and 2/3 times there. Sorry. Okay, then on this side over here, I would add my 2 to that negative 18. 3x is less than or equal to negative 16. And x is less than or equal to negative 16 over 3. And if I want to write that with a mixed number, just so I kind of have a better idea of where it goes on my number line, it would be negative 5 and 1/3. Okay, now I'm graphing this in the number line. I'm going to need closed circle at positive 6 and 2/3, and a closed circle at negative 5 and 1/3. And since x is greater than or equal to the 6 and 2/3, that's going to go to this side, and x is less than the -5 and 1/3 would go to the left side. All right, so two more, or actually three more. So for this one, we already have this isolated. However, we need to have it on the left side of the equation to properly identify that inequality sign. So I'm going to first just rewrite it. So this is on the left and the 24 is on the right. Now, when you go to put your sign in, because we reverse the two sides of where these items are, we have to change the direction of the inequality sign. Now, the way I like to remember it is if it's pointing to the 24 here, it still needs to be pointing to the 24 here. So that way you know they're still pointing to the same thing and opening up to the same thing. So now I can look at my inequality sign and see if it's an and or an or. And this is a greater than, so that would be an or problem. So now I can go ahead and separate it out. X minus 16 is greater than 24, or x minus 16 is, flip my sign, is less than negative 24. Then I just go to solve them. So x is greater than, and that becomes 40, or x is less than, and I believe that's -8. So on a number line, I would have a -8 somewhere over here, open circle, x is less than -8. And on this side, I'm going to have an open circle as well at the 40, and x is greater, so it'd go to the right. Okay, so now 4 and 5 are two special situations, and the reason why is because you'll notice that there's a negative on the other side of the inequality sign. So typically when we see a negative, that might raise a little flag, right? Because if you had an equal sign there, well, you can never have a negative distance, like we said in the beginning of the notes. So if you have an equal sign there, it's no solution because there's no absolute value that ever equals a negative. So automatically would be no solution. But these are inequality signs, so it's a little bit different. You actually have to kind of read into it a little bit more. So if we take a look at, for example, number 4, whatever's in this absolute value would have to be positive, right? So whatever's in here has to be less than -4. That doesn't really make any sense. There's no positive number that's going to be less than -4. Therefore, this problem would just have no solution. So if you get a negative value and you have an equal sign or a less than sign or a less than or equal to sign, any of those would automatically be no solution. Now, when you have a negative and you have a greater than sign like we do here, it's a little bit different because obviously whatever's inside this absolute value is going to come out as a positive because it's positive in its distance, which always has to be positive. But it's saying that this number must be greater than -1. Well, yeah, all positive numbers are greater than -1, so this could work. So what's going to happen is, let's take a look. So again, if it's greater, it would be an or problem. So let's see what this looks like. So if I do 1 plus 3/4 x is greater than -1, or I could do 1 plus 3/4 x is less than +1. So let's see what happens with this. So first I would subtract 1 over here. I get 3/4 x is greater than -2. Then I'm going to multiply both sides by my reciprocal. And then I'm going to get x is greater than -8/3. Or, and then on this side, I think I'm going to try to do it a different color just so we can compare. So subtracting the 1, so I get 3/4 x is less than 0. And then I'm going to multiply by my reciprocal on each side. So I end up with x is less than 0. Okay, so these are the two solutions we got. We ended up with x is greater than -8/3 or x is less than 0. So let's see what that looks like on the number line if we were to do one. So if I had a number line here, right? And the first one, this one, x is less than 0. So here's my 0, and it's an open circle. And I'm going to go less than 0. So that's going to go this way, right? Well, now, in a different color, I'm going to do the x is greater than negative 8/3. Well, negative 8/3 is like negative 2.66 or whatever. So let's say it's here, negative 8/3, open circle, but it's greater, so I'm going to go here. So if you'll notice, when you graph each of these solutions, every single space on your number line will be shaded in, because every single number that you have here is going to be, every possible solution would be in one section of this number line, and all of it's going to be shaded. So since it's an or problem, it doesn't have to meet all the criteria. It just has to meet one or the other. So any number that you put in there that would be less than 0 would work, and any number you put in that's greater than negative 8/3 would work. So that would pretty much cover every number that's possibly in existence, like all real numbers, right? So for example, if I were to check this, right, let's say I want to check. So I'm going to pick a number in this section here from 0 on. So I'm going to pick, I know this is weird, but I'm going to pick 4/3 because that will plug into this x easily. So if I go ahead and multiply this, and I pick 4/3 times 3/4, that's going to be 1, and 1 plus 1 is 2, and the absolute value of 2 is 2, and 2 is greater than negative 1. So we know that this section here is legit. Anything in there is an answer. Then I want to pick something in between the 0 and the negative 8/3. So maybe I'm going to pick negative 4/3, okay? And again, the main reason I'm picking this weird number is because when I put that in here, it's going to cancel the fraction out. So then that's 1 minus 1, which is 0. And the absolute value of 0 is 0, but 0 is still greater than negative 1, so we know that section works. And then if I were to pick a number over here, so I'm going to pick negative 12/3 this time for something in this section. Negative 12/3, 3's cancel. Negative 12 divided by 4 is negative 3. 1 minus 3 is negative 2. And that's going to come out as a 2, and 2 is greater than negative 1. So I know that those numbers work as well. So what's the real answer here? It's all real numbers. Okay, so just to review, anytime you have a negative on the other side of your inequality sign, if it's a less than or less than or equal to, it's no solution. If it's a greater than sign, it's going to be all real numbers or infinitely many solutions. Either one of those answers would work. Okay, so talking about checking our work, sometimes we have to decide, well, is a given number a solution? So all you would have to do in this situation is just plug in the different numbers and see if they work. So if I'm going to plug in a negative 4, I'm going to do 3 times negative 4 plus 8. And I'm hoping that that either equals 20 or negative 20, because both of those would come out to the 20. So 3 times negative 4 is negative 12. Negative 12 plus 8 is negative 4, and that comes out as a 4. But 4 does not equal 20, so this would be no, it's not a solution. For number 2, we're going to plug in a negative 1. Okay, 2 times negative 1 is negative 2. Negative 2 minus 9 is negative 11, and negative 11 does, the absolute value of negative 11 does equal 11, so this one would be yes. And finally, the third one, we have a negative on that m, but then we're substituting in a negative 5, so be careful, make sure you accounted for that double negative. Negative times a negative makes that 5 positive, and that then equals 14. The absolute value of 14 does not equal 4, so that would be no, negative 5 is not a solution. Okay, so now we're just going to solve these and then check your solution. Now, as far as the checking, you can kind of plug it back in, do it in your head. You could do it on your calculator. You don't have to write work for your checking, but it's a good idea to keep that in mind, especially when you're taking a test or a quiz. Okay, so first things first, we want to make sure we isolate this absolute value. So we want to get the 3 onto the other side. So we have 10 minus 4y and the absolute value, and that just equals 2. Since this is an equal sign, I'm just going to write it the two ways with the positive 2, and then I have to solve it again for the possibility that it could be a negative 2 inside there. So now I'm just doing my solving, subtracting 10, dividing by negative 4, making sure when we divide by a negative there, we end up with that positive 2. Then on the other side, subtracting the 10, and then dividing by the negative 4, and we get y equals positive 3. And again, you can just mentally kind of plug those numbers back in for y here and see if they make sense, right? Okay, so then the next one is negative 3n plus 22 equals 5. Luckily for us, the absolute value part is already isolated, so I don't have to worry about moving anything over. So the negative 3n plus 22 could equal 5, or the negative 3n plus 22 might equal negative 5. And now I'm just going to solve each of those possibilities. So negative 3n equals negative 17, and that gives us this fraction answer of 17 over 3. Make sure it's a positive because the two negatives do cancel out. And then on this side, we have negative 3n equals negative 27. And when we divide there, we end up with a positive 9. And then finally, we have this third question here. Now, we have to isolate the absolute value. So first thing we need to do is divide by this 4. So then that will leave us with 2/3 x plus 2, and then, of course, just a 10 on the other side. Now we can write our equation twice. 2/3 x plus 2 equals positive 10. 2/3 x plus 2 equals negative 10. Subtracting 2. 2/3 x equals 8. Then I'm going to multiply by my reciprocal on either side, which is 3 over 2. And then I end up with x equals 24 over 2, which simplifies to 12. On the other side, I'm going to subtract my 2. So I have 2/3 x equals negative 12. Multiplying by my reciprocal to cancel out that 2/3. And I end up with x equals negative 36 over 2, which simplifies to negative 18. All right, and then a couple practice problems with the inequalities. So all three of these inequalities, we have our absolute value portion isolated already. There's nothing we have to move over, divide by, or multiply by. So we're just going to start out by looking at each of our inequality signs and making sure that we're deciding if it's an and or an or. So this first one is a less than, so this is going to be an and problem. This middle one here is a greater, so that's going to be an or problem. And this one over here is a greater, so that's also going to be an or problem. So the first one's an and problem, so I'm going to put my 4m minus 9 in the middle, my less than or equal to 21 on the right, and then I'm going to match that inequality sign with the negative version of my 21 there. Now we're solving for that variable in the middle. So if I'm going to add 9, I got to do it on both the left and the right sides. So we have negative 12 is less than or equal to 4m, which is less than or equal to 30. And then we're going to divide everything by the 4 to get the m by itself. Negative 3 is less than or equal to m, which is less than or equal to, I believe that's 7.5, 7.5, or you could have 15 over 2. That's fine as well. Here's our answer. And I think there's a number line down here that we can kind of graph that on. Good. So again, -3, this would be a closed circle. 7.5, another closed circle, and shading in the middle. All right, let's take a look at number 2. All right, so number 2 was an or problem. And we could tell that because this is a greater than sign. So 2n minus 4 is greater than 10, or 2n minus 4 is less than -10. Adding the 4 on both sides, 2n is greater than 14. Divide by 2, n is greater than 7. Or do the other side of the equation for inequality. Divide by 2, n is less than -3. Okay, so now putting that on the number line, I have my negative number. And be careful, 7's positive, -3 is negative. Just because that ended up over on the left and this is on the right, you have to make sure you're putting them on the number line where they would actually be. So negatives are always on the left, positives always on the right. N is greater than 7 would be over here on this side. And n is less than -3 would be shading over here on this side. And it does look like two little oars on a rowboat, which is what we should expect in an or problem. Okay, and then this last one, another or problem, greater than or equal to. So -3y plus 10 is greater than or equal to 7, or -3y plus 10 would be less than or equal to -7. So subtracting my 10, -3y is greater than or equal to -3. Dividing by the -3. Now, remember when you divide by a negative in inequalities, you have to reverse the direction of that inequality sign. So I'd get y is less than or equal to +1. Or on this side, I have -3y is less than or equal to -17. And when I divide both sides by -3, again, that reverses my inequality sign, and a negative divided by a negative is a +17/3, or you might write that as 5 2/3. So either way, 17/3, 5 or 2/3. Now again, we have a +1, then more to the right would be the +5 2/3. Close circles here. Y is less than 1 would go out to the left. Y is greater than the 5 2/3 will go out to the right. And again, the or problem looks like two little oars on a boat. Okay, so the last thing we're going to go over today is these word problems with tolerance. Tolerance is the maximum acceptance deviation of a product from an ideal or average measurement. It's a margin of error, essentially. So one example that I use to kind of explain this is like temperatures or things like of that nature. So for example, if an acceptable range would follow this formula here, the actual minus the ideal. So we're going to be saying it's x minus the average. And then that would be less than or equal to the tolerance. We'll use T for that. The unacceptable range, we'll say X is minus the average, and that says greater than the tolerance. Okay, so what does that mean? So for example, I have some pets that require specific temperatures or humidity. So if you have a pet that requires a certain humidity, you might buy a humidity monitor. It's like a hydrometer or something like that. It's called hygrometer. I can never say it properly. But anyway, with any respect, I'm looking on Amazon, and one of them says that it has a margin of error or a tolerance of plus or minus 5 degrees, 5%, 5 degrees, So if I'm hoping to have my pet be at a humidity level of 80, then I know that if this meter is showing, 85 or 75, I'm probably pretty close. Now, if you are doing something, let's say, in a science lab, and you have to have a very, very precise measurement, temperature, measure of humidity, something like that, then you might be more particular in which type of meter you're going to buy. And maybe the $5.99 one on Amazon isn't going to cut it for you. So that's where we talk about acceptable range and unacceptable range. And it really has to do with how much variation are you willing to have in that measurement? So when we're doing this, we need to find a couple things, okay? So I'm going to just recopy the acceptable one because that's really the one that we're focusing on for the most part. What's acceptable? So x minus the average has to be less than or equal to the tolerance. Now, why less than or equal to? Why is that the one that's the acceptable? Well, think about it. If I'm talking about specific temperatures or humidity percentages, I don't want them to be more than the tolerance because remember the tolerance is like how far away it is from the ideal. So if I had a tolerance that's less than or equal to 5, that means my percentages are within 5%, and that's pretty good. But unacceptable would be when it's greater than your tolerance because then maybe that meter or that thermometer or whatever it is like way off what you're trying to go for and it's really useless at that point. So if we're looking for acceptable, we want it to be less than or equal to the tolerance. Now, in order to do this, we need, typically there's 3 pieces of information involved. There's the range, okay, so from what percentage to what percentage or what temperature to what temperature, whatever it is. Then there's going to be your average. And I'm going to write in parentheses midpoint because if you have a range of 2 things, the middle of the outer 2 numbers would be your average, right? And then the third thing we're looking at is the tolerance. And that is kind of like a standard deviation, if you've ever heard of that, but it's really like how far away you can go from that ideal or that average. So those are the 3 things. You're going to need to have at least 2 of them, right, to do the problem. So the length of a standard basketball court can vary from 84 feet to 94 feet. So that is our range. So our range is 84 to 94. So if we know the range, we can easily find the average because it's just going to be the midpoint of those 2 numbers. So you could add them up and divide by 2. You could count backwards on a number line till they get in the middle, and you should get 89 for the average. And then my tolerance, it says write an absolute value inequality that describes the possible lengths of a standard basketball court. Now, the tolerance is going to be how far away is the average from each of those numbers in your range. So how far away was the 89 from the 84 and from the 94? And it was 5 feet away. So now to write my thing, I'm going to use this little formula highlighted at the top. X minus the average, which is 89, is less than or equal to my tolerance of 5. Now, if you were to solve that, okay, you would get 2 numbers. You would have to add 89 to 5, and then you would also, well, this is a less than, right? So it'd be like an and problem. So if you were going to solve it, and then you'd have the -5 over here, and then you would add 89. So over here, when you add 89, you get 84. On the other side, when you add 89, you get the 94. So basically what's going to happen is if you solved this, right, you're going to get your range. That's what should happen. So 84 to 94, and then anything in the middle would be acceptable. Okay, so if we're talking about an acceptable, it's always going to be an and problem. The unacceptable would be the or problem because it would be the greater. Okay, so this next question is really good because it's very applicable to what's going on right now. So right now, with a lot of with COVID and everything else, we have a lot of temperature checks going on at different places, right? So I had to go to the dentist the other day. Before I could even go in, they had to take my temperature, make sure my temperature is within a certain range, right? Now, we know that the average temperature for a human is 98.6 for a healthy human, right? But what is the range? Because, there's always a little bit of variation. So there might be some people that tend to have a temperature that runs a little bit hotter or maybe a little bit cooler than 98.6. And right now, with what's going on, we have to have that in consideration because otherwise, you're not going to be let into places if maybe you're one of those people that always runs a little bit high or a little bit low. So there has to be some kind of acceptable tolerance. So we can't accept anybody with crazy temperatures, but we want to accept maybe people that are within close enough tolerance. Okay. So our tolerance that's deemed here, it says physicians consider an adult's normal body temperature to be within 1 degree of 98.6. So 1 degree tolerance would be acceptable. So they're saying, okay, so if you're 1 degree more than 98.6 or 1 degree less than 98.6, then you're still within the acceptable range. Okay, so when we write it, we would write x minus 98.6. And that's got to be that range less than or equal to 1. Now, of course, all you have to do is subtract 1 and add 1 to 98.6 to get your range. So if I subtracted 1, I'm going to get 97.6. And then if I add 1, I'm going to get 99.6. So if your temperature is in between those two amounts, then you're still considered to be normal, and then you shouldn't have any issues. But if you're over or under either of these, then that would be considered unacceptable, and then you might be infected or sick or something like that. Okay, next one, number 3. In a sampling conducted by the Air Force, the right-hand dimensions of 4,000 men were measured. The gathering of such information was useful when designing control panels, keyboards, gloves, and so on. So that's why they wanted to know what was like their average personnel's hand size. So 99% of the palm widths were within 0.37 inches of 3.49. So the 3.49 is the average. The 0.37 inch is the tolerance, because that was like that little deviation there. So we know that the average was 3.49. We know the tolerance was 0.37, and then we want to find the range. Okay, so x minus the average, which is 3.49, has to be less than or equal to 0.37. So then it says to graph the inequality. Now I use x instead of p, but same idea. So the range then is going to be what? 3.49 minus 0.37. And then you would have to do 3.49 plus 0.37, right? Because if you remember, we're really doing an and problem here. So that's kind of how you would solve that. You would have to add the 3.49 to each. So 0.37 plus 3.49 is 3.86. And on the low end, if I do negative 0.37 plus 3.49, I'm going to get 3.1. So again, if I'm graphing these, they're going to be filled in circles. My tolerance or my acceptable is anything that is within, including those two values there. Okay, and then finally, number 4, use the table giving the recommended weight ranges for the balls from 5 different sports to write an absolute value inequality that describes the weight range of each ball. So everybody remembers the whole scandal with the deflated footballs probably a couple years ago. So I guess whatever the weight was outside of that tolerance. It was in the unacceptable range, which is why it became an issue, right? So taking a look here, let's see. So for each sport, so for volleyball, okay, so these are the ranges, right? So we might want to know what are the averages, and we're going to write that over here. So my average here would be 270. For 600 to 650, my average would be 625. My average for the water polo would be 425. For lacrosse, it would be 145.5. And for football, it would be 14.5. Clearly, there's less tolerance there. Okay, so now the tolerance is how far are those average numbers I just came up with away from each of the two endpoints, right? So our average here, 270, that's a tolerance of 10 for volleyball. It's a tolerance of 25 for basketball, 25 grams for water polo. It looks like 3.5 for lacrosse. And for football, it is just 0.5. So much, much smaller tolerance. So then all I'd have to do for volleyball is x minus 270 is less than or equal to 10. That's how I would use this to write down an absolute value inequality to represent the acceptable weights. For what's next? Basketball, I would have x minus 625 is less than or equal to 25. For water polo, x minus 425 is less than or equal to 25. For lacrosse, I would have x minus 145.5 is less than or equal to 3.5. And for football, x minus 14.5 is less than or equal to 0.5. And obviously, if you did the and inequality for each of these, you would then get that range that they gave us in the beginning. Okay, and then the last one, a 5-pound bag of sugar can actually weigh from 76.4 to 83.6 ounces. Right? An absolute value inequality describing unacceptable weights. Okay, so we know that our range, this here is our range, right? So what's the average here? We average these two out. So because they're decimals, it might be easier to just put them in your calculator. 76.4 plus 83.6 divided by 2, and we get 80 ounces. Okay, and then what is our tolerance? So our tolerance is how far is 80 ounces away from 83.6 or from 76.4, and it's just going to be 3.6 ounces. So to write an absolute value inequality describing unacceptable, it's still going to be x minus that average, which in this case is 80, but instead of less than or equal to the tolerance, if it's unacceptable, we're going to do the opposite, which is greater than the tolerance, which is 3.6 ounces. Okay, and that is it for our lesson on absolute value equations and inequalities.